In today's video, we will be connecting the ideas between position, velocity, and acceleration. So we're going to start with a function. I'm going to write s of t equals negative 4.9 t squared plus 16t plus 4. So you should recognize this as a quadratic opening down, and some of you might even recognize that this is involving gravity. So the idea is we're throwing a ball up and it's going to come back down. So just going to make a little sketch of this function. So it's going to start at 4. It's going to, throwing a ball up, it's going to go up and it's going to come back down. And it reaches its maximum height. I'm going to put this as like 1, 2, 3, and 4. This is time measured in seconds. So it's like about 1.6. It kind of reaches its maximum height and it kind of comes back down like 3.5-ish. So here is my position of a ball. So this is height measured in meters over time. So how high is the ball at a certain time? So that is the graph of a position function, and position functions we usually would write as s of t, which I did. Okay, now we're going to look at changing this into a velocity graph. So let's look at this graph and think about velocity. So when you first throw the ball up, it's at a higher velocity, and as it's going up, the velocity is decreasing. It's getting slower, and then the ball actually stops. It's at rest before it comes back down, and then it will speed up down here. So the velocity function is always v of t, and it is the derivative of the position function. So it's the slope of the position function. So let's say, okay, where is it at rest? It was at that like 1.6 spot. So at 1.6 is when the velocity is 0. And the velocity is positive, but it's slowing down. It's decreasing. It rests. And then it comes back down, so the velocity is negative. And this is time in seconds. And then the y-axis is meters per second. Okay, so now the acceleration function. So the acceleration function is a of t, and acceleration is always the derivative of the velocity function, or it is the second derivative of the position function. Okay, so those of you that have taken physics should know this. The acceleration in this scenario is going to be a horizontal line at what value? It would be at negative 9.8 meters per second squared. So we still have time measured in seconds, but then this is meters per second or per second squared. Okay, now we're going to talk about velocity, speed, and displacement. So velocity, v of t. So remember, this is like slope. It's the derivative of that position function. So velocity is greater than 0 when a particle is moving right or up. And then velocity is less than 0, negative, when a particle is moving left or down. So I'm just bringing in the graph from the last slide. So let's think about this. So here, this part of the graph is velocity, even though it's decreasing, it's positive. So these are all positive y values. And that was when the ball was being thrown up. And then here, these are all negative y values, so velocity is negative when the ball was coming back down. And then velocity equals 0 when the particle is at rest. And then one more thing with velocity, if you are being asked about average velocity, I want you to think average rate of change. So if that's over an interval from A to B, average rate of change, that's the position function of B minus position function of A over B minus A. So there's average velocity versus, velocity at an instant, which would be the derivative. Okay, speed is the absolute value of velocity. So over here, velocity has a sign, positive or negative, and it's based on direction. Speed does not have direction. Speed is always positive. Okay, so now to determine if something is speeding up or slowing down, this you have to look at velocity and acceleration at the same time. So speeding up is when velocity and acceleration have the same sign. So that is when they are both positive or when they are both negative. And then you can probably guess slowing down is when velocity and acceleration have different signs. So maybe the velocity is positive, but the acceleration is negative, or vice versa if we've got negative velocity, but positive acceleration. Okay, and then displacement is the net change of position. So if you start here, a particle, let's say, moves 200 centimeters to the right, but then turns back and moves 50 centimeters left. Here's the starting and here is the ending. So the net change would be this, which is 150 centimeters. Okay, so now we're going to answer some questions about a function. So here's the function, a position function, s of t equals t to the third minus 3t squared plus 4. And this is position looking at centimeters and minutes. So if position is represented by this function, let's find the displacement for the first 2 minutes. So to do that, we're going to have to find the position at 0 and the position at 2 minutes and find the difference. So at 0, that's an easy one, it will be 4. And then when you plug in 2, let's see, we're going to have 8 and minus 12 plus 4, so that's actually going to be 0. So the displacement is where you end minus where you begin. So 0 minus 4 is negative 4, which means we moved left, which makes sense if we're starting at 4 and ending at 0. Okay, so now let's find average velocity of the first 2 minutes. So this is on the interval from 0 to 2. So we would have to find s of 2 minus s of 0 all over 2 minus 0. So we already found those y values. So 0 minus 4 over 2 minus 0 is 2. So negative 4 over 2. Negative 2 centimeters per minute. Okay, now we're going to find the velocity at time 5 minutes. So velocity, which means we need to find the velocity function, which is the derivative of the position function. So that's 3t squared minus 6t. And then we have to find that derivative at 5. So if you plug that in, 5 squared is 25 times 3. 75 minus 30 is 45 centimeters per minute. Okay, so then what is the acceleration at time t equals 5 minutes? So acceleration would be the second derivative of that position function. So that is 6t minus 6. So that at 5, 30 minus 6 is 24 centimeters per minute squared. Okay, speeding up or slowing down at t equals 5. So we have positive velocity and we have positive acceleration at 5. Therefore, they have the same sign, so they are speeding up, or the particle is speeding up. Okay, so now, last part of the video, we're going to answer some questions about a graph. So you can pause the video and you can kind of sketch the same graph that I just sketched. And I just want to make note that this is a velocity graph, not a position graph. So that is going to be, sometimes the hardest part is in calculus is knowing what you have, so therefore what are they asking you. So you got to make sure you know this is a velocity graph. Okay, so when is the particle moving right? Particle moves right when the velocity is greater than 0. So where is the velocity greater than 0? So this is the velocity graph. So wherever the velocity is positive is where the particle is moving right. So on the interval 0 to 2 and on the interval 6 to 8. So now when is the particle moving left? It's moving left when the velocity is less than 0. So where's the velocity negative? So right here, from 2 to 6, the velocity has negative values. So from 2 to 6. Okay, so now we want to determine acceleration. So we want to know, when is acceleration positive? When is it negative? So remember, acceleration is the derivative of the velocity. So here's a velocity graph, and then the derivative is always asking about slope. So let's see, slope is decreasing, so acceleration is negative here, and then boom, here it's increasing. So it's increasing, has an increasing slope from 4 to 7. So now, when is the acceleration negative? That's when the velocity has a decreasing slope. Decreasing from 0 to 4 and 7 to 8. Okay, so now where on this graph is there the greatest speed? So remember, greatest speed is the absolute value of velocity. So here 4 is the greatest velocity, but -4, that's also going to be the greatest speed because absolute value of -4. So it's just going a different direction, but it's still going just as fast. So the greatest speed is at t equals 0 and at t equals 4, because both of them have a velocity of, 4 and then absolute value of -4. Okay, now these last two questions are going to be kind of difficult. So where is the particle speeding up and where is the particle slowing down? Okay, so speeding up is when velocity and acceleration have the same sign. So let's first look at when they're both positive, and then we can look when they're both negative. Okay, so velocity is positive here, but acceleration is negative because it's decreasing. All right, velocity is positive here, and then here it's increasing, so this is where acceleration is positive. So from 6 to 7 is the only spot on this graph where they're both positive. So both positive from 6 to 7. Okay, now let's look where they're both negative. Okay, let's find velocity negative. So here is where velocity is negative. Okay, and acceleration is negative when it's decreasing. So from 2 to 4 is when they're both negative. So that means on these intervals is when the particle is speeding up. Okay, so now slowing down is when they're on different signs. So let's find when velocity is positive, but acceleration is negative. So here velocity is positive, but acceleration is decreasing. And over here, velocity is positive, but it's decreasing. So from the interval 0 to 2 and 7 to 8. Okay, so now let's look at the other one. Where's velocity negative, but acceleration is positive? So right here, because velocity is negative here, but acceleration is positive here. So from 4 to 6. So in all, not 4 to 3, 4 to 6, all of these 3 intervals is when the particle is slowing down. So there is, I just gave you a lot of information, but it's very, very, very important for the rest of this year. So good luck.